All right, so this booth looks super nerdy. We got a bunch of pipes. We've got some chemicals on them here. We're not really sure what we're looking at. We got some fun meters. So Steve and I, being nerds, we had to stop by as engineers. I'm here with Steven Bardey, and the company name is?
Aerleum.
Aerleum.
Yeah.
And what is this contraption representing here?
So at Aerleum, what we are doing is making fuels out of air. So here, what you can see is our reactor containing our patented material, and this reactor is able to catch the CO2 and transform it directly into different kind of fuels. And the first fuel we are doing is called methanol.
Methanol.
Yeah.
Oh, okay.
And methanol is used to power, for example, ships. It's also used to make sustainable aviation fuel, and it's also a building block for the world chemical industries, making plastics, paints, solvents, all that kind of crucial commodities.
Okay, so air. Now, is this a simplification I'm looking at here, or is this really representative before I describe it?
It's a kind of simplification, but more or less...
Because we have a very small pipe that says air,
Yeah.
and it travels down, and we got a couple of little meters here, and then powered by air, and then magic happens, and it's methanol.
Exactly.
I think there's probably a little more to it than that.
Yeah, it's a bit simplified, but basically what happened is air is going through a larger pipe than this one inside the reactor. Then the CO2 is trapped by our material. You can figure it as a sponge. So air passes through a sponge, the CO2 is trapped by the sponge. The rest of the air is released in the atmosphere. So air without CO2 released in the atmosphere. Once we have saturated our sponge, so our sponge cannot take more CO2, we stop everything, we stop flowing air, we flow hydrogen, which is the reactant that will react with the CO2. We heat up the reactor, and magic happen at the surface of our sponge, the reaction.
Maybe I could call it patents happen.
Sorry?
Patents happen.
Exactly.
This is in the reactor you're talking about, right?
Yeah. It's this. Actually, this one is the reactor we have in our lab to make our optimization on material, etc. But the one we are building right now in our company in Paris is human toll.
Okay.
Where does the carbon go?
Sorry?
Where does the carbon go from the CO2?
Where is
The carbon.
Where does the carbon
The
go?
C in CO2, where does the carbon go?
Somewhere. I see. Is there carbon in this?
Yes,
Okay.
it's CH3OH. Methanol is the first alcohol you can do.
Okay, Steve, you explain the answer, what he said to me.
Methanol has carbon as part of
Okay,
it.
so carbon's not a byproduct, it's part of methanol.
Exactly. Carbon is trapped inside the methanol.
Okay, you didn't have enough.
Me is what confuses. It's not.
ME is not a chemical, so you didn't have enough. We'd have to walk all the way around to read the label if it had the
Exactly.
CO2. Okay.
ME is for methyl actually, and methyl is CH3.
Okay.
That's why.
Okay, there we go.
Well,
So
that's for chemists.
this sounds like it's going to solve the problems of the world.
Yeah, it could. We just need to scale up the technology. Right now, we are making 100 of kilos per month of methanol. So 100 of kilos per month of products means we capture 140 kilos of CO2 in the atmosphere. So it's already kilos, but it's not enough to solve our big problem. But yeah, once we will be at full scale, that could change the way we produce commodities.
So how much energy do you have to put into this to cause this to work?
Actually, this process is one of the most, let's say, efficient process we have in this domain. We achieve 55% energy efficiency. So it's the energy we put inside this process. We recover more than the half at the end with the power of the methanol itself.
So are you energy neutral, or are you putting more energy in? You need to be getting the energy from somewhere.
Yeah, you always, more or less, always put more energy than
That was a
you
test.
recover. Yeah, because it's more or less like for example, a thermal engine. I think it's below 30% the energy efficiency. Here we go up to 55%. Because of this patented material, which can combine different steps. So we remove a lot of energy-intensive steps that are actually used in the industry, in this industry. So that's why we are the best in that market.
Do you have a method for using the methanol to power this?
Not yet, but actually that's a good idea.
Very good, very good. So if people want to learn more about what you're doing, I'm guessing this is not a product on the market, but if they're interested in this, where would they go?
They can have a look at our website, www.aerleum.com.
And Aerleum is spelled AERLEUM.com.
Yeah, actually it's like petroleum, but we remove petrol, which is taking the carbon in the earth, with air. And
AER.
air, it's AER, Greek or Latin base.
Very good, very good. Well, thank you very much. We all wish you the best of luck
Thank you so much.
because we need it.
Yeah, thank you so much.